I'm going to finish the chapter 1 test review. We had gotten to question 9. Question 9 states the number of students in thousands of osteopathic medicine in a country can be described by S equals 0.028 t squared minus 4.8 t plus 213.87, where t is the number of years after 1990. Using a graphing utility, I'm going to use our calculator to graph this function on a viewing window of 0 to 17 in the x direction and 0 to 300 in the y. Use the graphing utility to predict the number of students of osteopathic medicine in the country in 2024. And I'm going to use the table to figure that out. All right, so let's get this thing graphed. All right, let me share this. Okay, so here's my calculator, and I'm going to go to the y equals, and I'm going to clear out what I have in there, and I'm going to put in this function. So we have 0.028 x squared minus 4.81 x plus 213.87. And they ahead of time tell me what the window is going to be. So I'm not going to even graph this. I'm going to go straight to the window. And in the x direction, we're going to go 0 to 17. And I'm going to leave the scale of x as 1. And then the y min, they tell me 0 to 300. And I'm going to go ahead and leave that y scale as 1 also. Although normally I'd probably change that to 10 or 50. Actually, they do at the bottom here ask me to change the scale to 30. So that's actually part of the problem. So I'm going to change that scale to 30. And I think I'm good to go there. All right, so we're ready to graph. Hit the graph button. All right, so that's what my graph looks like. And of my choices, and we'll go back and look at that on the PDF in just a second, the first choice is the better of the two choices that I'm given here. And then it asks me in the problem, in 2014, 24, 20, try that again. In 2004, the number of students of osteopathic medicine in the country will be what? All right, so this graph is the number of years since 1990. So what would X be if the year is 2004? So I'm going to get out of here. I'm going to calculate that. So 2004 minus 1990 is 14 years. So what is the Y value when the X value is 14? So let's go to our table. And let's find X is 14. Now I am going to go over and I'm going to arrow over to highlight that value because my calculator is rounding off to 2 decimal places. And I don't want 2 decimal places. The problem asks for 3. So I'm going to arrow over and highlight that value so I can see it to 3 decimal places. So it's 152.018. Okay. So I highlighted that first graph, chose that first graph, and then in 2014, I'm going to have 152.018. All right, next problem, problem 10. The amount of federal tax per capita per person can be modeled by the function s equals 8.4151 t to the third minus 57.29 t squared plus 544.71 t plus 5190.1, where t is the number of years after 1995. This entire problem, almost in its entirety, is aligning data. So what are the values of t that correspond to 1998, 2019, and 2020? So if t is the number of years after 1995, then what would 1998 be? Well, 1998 would be 1998 minus 1995, which is 3. So t would be 3. What would be 2019? Well, 2019 minus 1995 would be 24. And what value of t corresponds to the year 2020? 2020 minus 1995 would be 25. Okay, so now find s equals f of 5. So I'm going to evaluate this function at 5. So what year is that? What year is that? Well, if this is 5, that's going to be 1990 plus 5. Is that 1995? And so what is f of 5? F of 5 would be, let's plug and chug, excuse me, type that in right. It'd be 8.4151 times 5 cubed minus 57.29 times 5 squared plus 544.71 times 5 plus 5190.1. So my handy dandy calculator says that would be made a mistake. I'm gonna fix it in just a second. That would be 7533. And they tell me to round to the nearest integer. So I'm gonna round that off to the nearest ones place. Where's my boo-boo? Did you see it? My boo-boo is in the second part. Right there. If we're evaluating f of 5, that is 1995 plus 5. It's the number of years after 1995. I even highlighted that, still made a mistake. 1995 plus 5 is the year 2000. So let me correct my mistake. All right. So now what do we want to find? What X-min should be used for the viewing window if we're going to graph this, and what X-max should be used if we're going to graph this. And I don't have to graph this to figure out what the viewing window is. If we're talking about X values, we're looking at after 1995. So t equals 0 is 1995. So I probably want to start at 0. And then what's my last value? 2020. So I probably want to end at 2020, which would be t equals 25. So my viewing window in the X direction, I probably want to go from 0 to 25. All right, problem 11. If the linear function has the points 2, -3, and -9, -8 on its graph, what is the rate of change of the function? Rate of change is slope. That's slope. So we're going to find the slope of a line that connects those 2 points, change in y over change in x. So I'm just going to use -8 minus -3 minus a -3 over -9 minus 2. So I get -8 plus 3 minus minus gives me plus over -11. -9 minus 2. We're at -9. We go 2 more in the negative direction, so we end up at -11. So is that -5 over -11? Which would be 5 over 11. Negative divided by negative gives me positive. All right, problem 12. The monthly rates for life insurance policy for males aged 27 to 32 are shown in this table. Choose the correct type of function to model the data in the table. Is it an identity, which we didn't really even talk about, or a constant function? And why is this constant? This is constant because the y value doesn't change. The premium, the dollars per month, the y value is constant. If the y value is constant, this is a horizontal line. It's a constant function. The slope is constant. So it is a constant function. The equation whose graph contains the data points in the table is, if it is a horizontal line, a constant function, it has the equation y is equal to a constant. So what is y equal to? Y is equal to 10.22. So the equation of that linear function that models that data is y equals 10.22. What else does it ask me? The slope of the graph of the function is, if it's horizontal, if y is constant, its slope is 0. Okay. Problem 13. Oh, the rate of change of the data in the table, also 0. Almost left that part off. The rate of change of the data, y is constant, the rate of change is equal to 0. All right, problem 13. The life expectancy of American women, T, years after 1950. So we have a line data. T represents the number of years after 1950. Is given by A of T equals 0.1 T plus 72. Complete parts A through C below. Find and interpret the A-intercept of the graph of this function. Choose the correct interpretation of the A-intercept. Okay, the A-intercept, since we're looking at a function of A in terms of T, since A is the output given the input T, the A-intercept is the Y-intercept. They're the same thing. So the Y-intercept, the A-intercept is the constant part of that linear function. So the A-intercept is 72. Okay, so let's interpret this now because we got 2 different choices. So the first choice is the A-intercept is blank, which means the life expectancy of American women was 0. No. The life expectancy of women in America is never 0. So it's certainly not A. So let's read the second one. The A-intercept is, it is 72. Which means the life expectancy of American women was 72 in the year 0, or since we're looking at the number of years since 1950, that would be 1950, because that's where we're aligning our data from. Time t equals 0 is equal to the year 1950. Okay, what is the slope of the graph of this function? Well, the slope is the number you're multiplying times your variable. So what are we multiplying times t? We're multiplying by 0.1, so our slope is 0.1. Let's interpret this. Okay, so the rate of change of this function is 0.1, and then we have to decide what our units are. So slope is, it's going to be the age per year after 1950, because it's a line data, per year of after 1950. Let me write this correctly. Just looking at the function. So it's going to be the age of the woman after the year 1950. So which one is that? Years after 1950 per years of age. No. Years of age per year after 1950. Well, that sounds better. Years per life expectancy. No, it can't be that. Life expectancy per year. No, it's going to be this one. It's going to be the second choice. So it's 0.1 years of age per year after 1950, because that's what T represents. That's what the bottom denominator of that slope represents. It represents the number of years after 1950. So the only choice is part 2. Okay, problem 14. Suppose the monthly total revenue for the manufacturer of golf balls is R of X equals 1.58x, where X is the number of golf balls sold each month. Part A, what is the slope of the graph of the total revenue function? What's 1.58? It's the number you're multiplying times X. Part B, what is the marginal revenue? Marginal revenue is equal to slope. It's the slope of the revenue equation. Okay, so it's 1.58 also. All right, so let's do some interpretation here. Choose the correct interpretation. So what does this represent? Well, it's dollars per number of golf balls. I mean, if I look at the way it's described, X is the number of golf balls. So the inputs goes in the denominator of my slope equation. So and R is dollars. So it's going to be dollars of revenue per golf ball sold per month. So which one is that? The revenue will increase by $1.58 for each additional golf ball sold in a month. Well, that sounds right just right away. Each month, the revenue increased by 1.5. No, that's not right. The revenue will decrease. No, it's not negative. Each month, the revenue, no, it's not going to decrease. The revenue slope is positive. So revenue is increasing. So the second two choices, no way, no how. It's between the first two choices, but the second choice is increased by 158 per day. And that's not what's in the denominator of my slope equation. What's in the denominator of my slope equation is the number of golf balls sold. So it has to be A. Okay, problem 15. Write the equation of line passing through the point with slope. So we're just going to use point slope equation to find the equation of the line with slope, -6/7 and a 0.7, -8. So y minus y1 equals mx minus x1. Okay, so let's plug and chug. We're going to put -8 in for y sub 1. Y minus a -8 equals, my slope is -6/7 times, in parentheses, x minus 7. We're plugging in 7 for x. Okay, so let's do a little arithmetic here. Over on the left-hand side, I have y minus a minus. Minus a minus gives me plus. So that is y plus 8 equals. And then I'm going to distribute the -6/7 across. We distribute it across the x. That gives us -6/7 times x. And then to distribute it across the -7. So we're distributing a negative across a negative, which is going to give us a positive. And then we're multiplying 6/7 times 7/1. And to multiply fractions, we multiply straight across, but I can cancel the 7 and I get 6. So that's +6. Okay, and then I'm going to subtract the 8 from both sides. And we get y equals -6/7 x minus 2. 6 minus 8 is -2. So we have y. And I do, you see it's, let me point something out here. Let me highlight this. It wants the equation. So it does want you to put the y equals there. All right, problem 16. For the function y equals x squared, compute the average rate of change between -5 and x equals 1. So to find the average rate of change, remember, we evaluate the function at those two values, 1 and -5, and then we divide that by 1 minus a -5. So we need to evaluate this function at 1 and at -5 to figure out what those numerator values are. Okay, so let me write that over here somewhere where I got all the room. So f of 1 is 1 squared, which is 1, and f of -5 is -5 squared. And remember, whenever I square a real number, I'm going to get a positive. -5 times -5 is 25. So we have 1 minus 25 over 1 minus a -5 would be 1 plus 5. So that is -24 over 6, which is -4. So the average rate of change of that function between -5 and 1 is -4. Okay, next problem. Problem 17. Assume that the growth of the membership of a country club was linear from 1996 to 2000, with a membership of 162 in 1996 and a rate of growth of 669 per year. Write the equation. So this one, they give us the rate of growth. Rate of growth, let me highlight that. Rate of growth. That's the slope. And it's going up, so the slope is going to be a positive number. So the slope is 669. And they tell us the initial membership. So they tell us that we're aligning this data. 1996 was 162. So if we're aligning this data, we're going to start at that initial amount. So that's the y-intercept. Was what's 162? So then I can just write this equation. Y equals 669 x plus 162. And they use p, but that's okay because I just need to type in the equation 669x plus 162. Use the function to approximate membership in 2002. Well, this is years since 1996, I believe. So x will be 2002 minus 1996. We're aligning the data. So x equals 0 corresponds to the year 1996. So that is 6, I believe. And so we're going to evaluate this function at 669 times 6 plus 162. So the membership is going to be 4,146. 76. I don't know what I just said. 4,176. All right, last problem, problem 18. Woohoo! So there are 18 questions on the test. 18 questions on the review, 18 questions on the test. A company finds it can produce 30 heaters for $8,200, while producing 10 heaters cost $10,800. Express the cost y as a linear function of the number of heaters x. So these two statements give us two ordered pairs. So 30 heaters cost us $8,200, and 40 heaters cost us $10,800. So what are my two ordered pairs? My two ordered pairs would be 30, 8,200, and what? 40, 10,800. So we're going to use those two ordered pairs to create the equation, to derive the equation. So slope is the change in the y's over the changes in the x's. See if I can get this to right. So change y 10,800 minus 8,200 over 40 minus 30, which I think that's 10. So that's going to be, my handy dandy calculator says 260. And then I can pick either one of those points to put in the slope, point slope equation. Okay, so we have, let's just use the first point since it's the first point. Y minus 8,200 equals, what do we get for slope? 260, x minus 30. Our x value for that y value of 8,200 is 30. So let's do a little distributive law here. We're going to distribute the 260 across. So we have y minus 8,200 equals 260 times x, 260x. When we distribute 260 times the x, we get 260x. It helps if my pins will continue to write. Minus, what's 260 times 30? Take my handy dandy calculator out, and I get 7,800. And then to isolate y, we're going to add the 8,200 to both sides. Since we're subtracting it on the left, we're going to add it to get rid of it. Whatever I do to one side, I must do to the other. Plus 400. Okay, so my equation is 260x plus 400. And that is the end of the review.